Hi guys, my name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I will be looking at differential equations, and this lesson is a continuation of our previous lessons in differential equation under the topic variable separable. So we said in previous lessons, if you have a differential equation and you have a scenario wherein you can separate out of the expressions that are x only and the expressions that are y only on separate side of the equations, then it means that you can apply variable separable. If that cannot happen, then we can also use other methods like trying to manipulate the differential equation such that we can reduce it to variable separable. If that is not also possible, we can use other methods like homogeneous differential equation, exact differential equation, integrating factors, and Bernoulli equations, and just every other method that we understand under solving first order differential equation. So this is a first order and degree one, first order, first degree differential equation that we need to find a general solution of. So let's get started. Now we said problem is x squared plus y times x squared dy plus y squared plus x y squared dx equals to 0. So we're asked to find the general solution for this equation. So how do we go about finding the general solution of this equation? So like we said, when you're dealing with differential equation, especially first order, the first approach is to test for variable separable as to whether the variables can be separated. So write an equal sign like this. Now, the term with dy, I want it to be on this side of the equation. So I write dy on this side. This x squared plus yx squared. Now, so this term, I want to send it on the other side of the equation. So I have negative y squared plus x y squared dx. So the next thing I need to do now is to see how best I can factor out. So I have x squared and x squared, so I can bring out x squared. I'll be left with 1 because x squared into x squared is just 1. X squared now goes into this, x squared and x squared will cancel, you'll be left with y. And now I'm left with dy now equals. So likewise with this side, y squared can also come out. So when y squared comes out, we left with, now y squared into y squared is just 1. And then y squared into this, when we say y squared into this is what we mean. Y squared go into y squared. So this here 1, this here 1. And then if we say y squared into this, we mean that y squared go into x y squared. So this and this will cancel, you'll be left with x. So this side now is just x dx. So now we further see that in this parenthesis, we have all y. In this parenthesis, we have all x. So since this is the x, and we need every expression here to be in x, we must get rid of this y squared. Also, since this is y, we need only y expression here, so we must get rid of this x squared. So we divide both sides by x squared, and then we divide both sides by y squared. So this y squared will carry this one out, x squared will cancel x squared, so we'll be left with 1 plus y dy divided by y squared equals negative. So this is 1 plus x all over x squared times dx. So since I have now separated the variables, my target now is to integrate both sides. So I have the integral of, now I can take 1 over y squared, 1 over y squared dy plus, I can also take the integral of y over y squared minus, I can take the integral of 1 over x squared dx, and then this negative now because it's affecting each term, minus the integral of x over x squared dx. So now the rule says the integral of x raised to n dx is equals x raised to n plus 1 or over n plus 1 plus some arbitrary constant c, where n should not be equals to minus 1. So n can be any other expression. N can be 1 over 2, n can be negative 2, n can be 5, negative 5, but n should never be minus 1. When n is minus 1, that's when we just have the integrand to, let's say we have the integral to be ln of x, because you know that's natural logarithm. So since this is y raised to the second power, this 2 now is not minus 1, or it's not 1, because when it is 1, it's just when it is just 1 all over x, meaning this power is 1. You can't send it up, because if you send it up, it will be x to the power minus 1. And we said that this n should never be minus 1. So since this is now 2, we can send it on top. It becomes minus 2. See why? We can reduce this 1 now over y dy minus, we can also send this x on top. It becomes minus 2 dx. And then we reduce this x into itself 1 times x into x squared. So it's 1 over x. So we cannot send this y on top because the power here is 1. Likewise with this. So this is just equals to the ln of y. Now this is x to the power minus 2 plus 1 all over minus 2 plus 1. Minus this is just also ln of x. And this side is minus 2 plus 1 all over minus 2 plus 1. So plus some arbitrary constant c. So we further simplify. Now we have y raised to the power, this is minus, this will now give us y raised to the power minus 1 all over minus 1, and then plus ln of y equals, now this is minus x raised to the power minus 1 all over minus 1 minus the ln of x plus c. So now our target is to just simplify the problem, right? Because we've already found the general solution, but we just want to simplify the problem. So let's further simplify. We can reciprocate this y. So it becomes negative 1 all over positive y. And then this negative is positive, right? So we can say plus ln of y equals, and then this side we have what do we have here? This is 1 all over x minus ln of x plus c. So again, we said we want to simplify the problem further. So we can decide to group all of the terms with ln. So if we group all of the terms with ln, you know, we will have ln of y plus ln of x equals, now this side is 1 over x, and this side is plus 1 over y plus arbitrary constant c. So this ln of a plus ln of b is equal to ln of a times b. So this can just be the ln of xy plus, or that's equal to 1 over x. So we even think of finding the LCD for the three of them. You just have the LCD to be x and y. So we have our x going to xy, x and x cancel, you left with y. So this is y plus y goes into this, y and y cancel, you left with x. So it's just x plus 1 going to this is just cxy. So Now I want to solve for y, for example. We just want to get rid of this ln. So we know that e raised to the ln of a function is just equals to that function. So if we take e on both sides, we say e, the ln of xy, this will just lead us to xy equals, we'll take e on this side as well, y plus x plus cxy all over xy, right? So we will just have this now to be equal to e raised to the power y plus x plus cxy all over xy. So we can decide to divide both sides by x. There are so many different solutions or different arrangements that we can have, for this general solution. So many different solutions. Because it is general, you may not have a definite form of it. Because somebody may say, I will just leave it like xy equals to this. Somebody may say, okay, I will just leave it like this. Another person could say, I could leave it like this. Another person could say, I may not divide also. So since it is a general solution, you may not have a particular solution, for all of the different cases. So whatever way that your teacher wants you to, or wheresoever way your teacher wants you to stop, whatever required answer that you were given to stop at, you can just stop at those answers. But I'm only providing some eye-opening stuff for you so that you have a broader understanding of how to further simplify the general solution of a differential equation when you are asked to do so. So yeah, this could be some of the solution of it. Yeah. Oh God, thank you, Father. So just stop here. So if you like, you want to divide both sides, you can do that. You want to stop here, you can stop here. Whatever the case might be. Thank you. See you in our next video.